Hello everyone, I am Ritik Salar and I am studying a BTech AML degree in Savidanjali College. Today we will be saying about A-star searching algorithm. A-star searching algorithm is a greedy search which algorithm which minimizes the heuristic h of n function, which is an estimated cost from a node n to the goal state. However, although greedy search can considerably cut the search time efficiently, it is neither optimal but not complete. Uniform cost search optimizes and minimizes the cost g of n from the initial state to n. UCS is optimal and complete, but not efficient. So there's a new strategy combining greedy search and UCS to get an efficient algorithm which is complete and optimal. Let us look into it. A star uses a heuristic function which combines g of n and h of n as mentioned in the earlier stage. F of n is equal to g of n plus h of n, which is the algorithm for our A star search. G of n is the exact cost to reach node n from the initial state, whereas cost so far up to node n. H of n is an estimation of remaining cost to reach the goal. So let us get into the algorithm. First, we have to start with the open containing only the initial node. So the node's g value to 0, its h value to whatever it is, and it is f dash value to h dash plus 0 or h dash. Set close to the empty list. Until a goal node is found, repeat the following procedure. If there are no nodes on open, report failure. If not, pick the node on open with the lowest flash value, call it best node, remove it from open, place it on closed. See if best node is a code node. If so, exit and report a solution, either best node. If all we want is the node or the path that has been created between the initial state and best node, if we are interested in the path. Else, generate the successors of best node, but do not set the best node to point to them yet. First, we need to see if any of them have already been generated. For each such successor, do the following. First, we have to set successor to point back to best node. These backward links will make it possible to recover the path once the solution is found. Then we have to compute g of successor, which is equal to g of best node plus the cost of getting from best node to the successor, which is f of n is equal to g of n plus h of n. See if successor is the same as any of the node on open. That is, it has already been generated but not processed. If so, call that node old. Since this I node already exists in the graph, we can throw successor away and add old to the list of best node successors. Now we must divide whether old's parent link should be reset to point to best node. It should be if the path we have just found the successor is cheaper than the current best path to old. So see whether it is cheaper to get to old via its current parent or successor via best one. By comparing their G values, if old is cheaper, then we need to do nothing. If successor is cheaper, then reset old's parent link to point to best node. Record the new chapter path, cheaper path in G of old, and update F dash, that is old thing. If successor was not open, see if the closed. If so, call the node on close to old and add old to the list of best node successor. If successor was not already on either open or closed, then put it on open and add it to the list of best node successors. Compute f dash of successor, which is equal to g successor plus h dash of successor. Now let us look into a what to say formal overview of the A-star search. Here we have the g of n, which is the function which will be from the initial state to the end state, and we have the h of n, which is from the nth state to goal state. So we have the f of n function, which is defined as g of n plus h of n. We have constructed a graph which has the following weights are the from a to c, a to b, and from each node to each node. So we'll be calculating the heuristic function. Heuristic function values are listed over here. After calculating the heuristic function, we'll be implementing the search. First, we'll start from the starting node. Then we'll be calculating for the next set of nodes. We have previously seen here A has an edge from C to C, E, and B. So we'll be having C, E, B. Will apply the formula, which is f of n is equal to g of n plus h of n, and we'll get the values 118 plus 329, which has the value C447. Likewise, we'll be calculating for each node. Each node will be calculating the heuristic function. After calculating the each function's heuristic function value, we'll be getting the optimal solution. So this will be the optimal solution. We'll be reaching the goal state through A, E, G, H, and I. This is the optimal for our graph. So we'll be calculating how good is A star. We'll be saying how good is A star. Memory usage depends on the heuristic function. If g of n is equal to constant, h of n is equal to 0. Then A star is equal to breadth first search. If h of n is a perfect estimator, A star goes straight to good. But if h of n were perfect, we do not need to perform the search itself. Quality of solution also depends upon the h of n function. It can be proved that if h of n is optimistic, it never overestimates the distance to a goal. Then A star will find the best solution to the solution question problem statement will be providing, which is the shortest path in code. Where should we use the search techniques? If the search space is small and there are no other variable available techniques, or if there is not worth the effort to develop a more efficient technique, then we have to use the search techniques. Then the search space is large and there is no other available techniques and there exist good heuristics, we'll be using this A star searching algorithm. So in the conclusion, we'll like to say that frustration with uniform search led to the idea of using domain-specific knowledge in a search so that one can intelligently explore only the relevant part of the search space that has a good chance of containing the goal state. These new techniques are called as informed heuristic search strategies. Even though the heuristics improve the performance of informed search algorithms, they are still time consuming, especially for large spaces. Thank you.